So imagine that you are trekking in the Andes or Himalaya mountains, where the air is thin and oxygen is in short supply. You're accompanied by some fellow trekkers, as well as some local guides and porters. Breathing is difficult and your movements are slow. Some members of your group display signs of altitude sickness, but the porters, apart from being encumbered by your luggage, don't seem to be suffering at all. The explanation for this scenario seems fairly straightforward. The porters have lived in this low oxygen or hypoxic environment for hundreds of generations and can cope better than people who spend all their life at sea level. But now, turn your attention away from the mountain and into the aquatic environment, a freshwater wetland. Here, oxygen can change from abundant to rare in just a matter of hours. And this can be quite severe near human settlements, as increased nutrients from farms and cities can reduce the oxygen in the water. For fish, the severity of these changes can mean the difference between life and death. And for an ever-growing human population, this could mean the difference between having dinner and going hungry. My research is focusing on the ability of fish to tolerate low oxygen, and in particular, how this differs according to their population of origin. And by sheer coincidence, my study species just happens to be one of the best eating and angling species in all Northern Australia, the barramundi. Now, as we move towards the equator, two things occur in the water. First, water temperatures increase, and second, the amount of oxygen that water can hold decreases. In the wild, barramundi occur as multiple distinct populations that associate with river systems, kind of like salmon in British Columbia. And you might expect then that those barramundi living closer to the equator and that have less available oxygen than their relatives further south will be able to cope with hypoxia better, just like the porters up in the mountains. And when I measured the hypoxia tolerance of barramundi using flow-through chambers, I found that there was essentially no difference between any population right across Northern Australia. What my research has shown, however, is that irrespective of where they come from, barramundi can improve their ability to use oxygen over time and can become more tolerant. And what does this mean for the future? Well, barramundi are a pretty tough fish, but like everything, they do have a breaking point. By discovering where this breakpoint occurs and how it changes, we can better manage natural waterways so that our children will have fish to eat. And with no difference between populations, barramundi appear quite resilient to change, so we should all be able to enjoy catching and eating barramundi for many years to come. Thank you.